All right, today we are going to learn about how to combine like terms. I realize this is review for a lot of you, but it doesn't hurt to hear it again. This should be something that you learned in Math 7 and something that you will need, especially when we start Chapter 1 in pre-algebra. So, like terms are two or more terms that have the same variable raised to the same power. That's important. A variable, remember, is like a letter x, and a power is like x squared. The 2 would be the power. The goal of combining like terms is to create an equal expression with fewer terms. Okay, we're trying to simplify this big, ginormous expression into something a little bit more manageable. Another vocab word is a constant. Constants are basically numbers. So 4, 8, 0, -3 are all constants, and they're all considered like terms because they don't have any variables. So you can combine constants together. So let's work on simplifying some like terms. Once again, if you can't write that small, pinch it in to make it super, super big. It gets a little blurry, but that's okay. Letter A, 5x plus 4x. Those both have the same variable with the same power. The power is just 1. You just don't have to write it. So when that's the case, you circle them and combine them. So 5x plus 4x is 9x. B, we have m's. 8m plus -3m. 8 plus -3 is 5. So that's 5m. Part C, we have some h's. 5h. Plus -3h is 2h. And then this 6k doesn't have anybody to combine with, but that doesn't mean you get to forget about it. It needs to be brought down into your final answer. And D, 1.2w plus 4.2w, that's 5.4w. And then you have another 5w to combine. So this final answer would be 10.4w. 4k plus -7k is -3k, and -3k plus 3 is your final answer for part E. And then F. Sometimes your like terms won't be next to each other, so this sign always goes with the term that comes right after it. So M is really 1m, so 1m plus 3m is 4m. Don't forget about the plus 5. Now our examples get a little bit more complicated because we're going to throw in the distributive property that you learned the last time you were in math. And we're going to have to use the distributive property and then simplify by combining like terms. You have to distribute first. Okay, so remember, let's use our claw method. 2x, 2 times x is 2x, and 2 times 3 is 6, plus 3x. 2x plus 3x is 5x. 5x plus 6 is your final answer. If you still need to circle to combine your like terms, please do that. Part B, 3g minus 7 is 3 times g, and 3 times -7 is -21, plus 4. Now combine your like terms. -21 plus 4 is -17, so this is 3g minus 17. Part C, distribute first. So you have 4x, that doesn't need to be distributed, it just gets brought down. 6 times x is 6x, 6 times 5 is plus 30. 4x plus 6x is 10x. Don't forget about your plus 30. Letter D, distribute first, not the 6, just bring it down. 3 times m is 3m. 3 times -4 is -12 plus 8. So your only m term is the 3m, and then you have 3 sets of numbers to combine. So 6 minus 12 is -6. -6 plus 8 is positive 2. Letter E, you've got to distribute twice. So this is 2g plus 6 plus 3g minus 21. Combine your g's. 2g plus 3g is 5g. Combine your constants. 6 minus 21 is negative 15. And lastly, part F, 2.5 times F is 2.5F. 2.5 times negative 4 is negative 10. Drop down your plus 10. Negative 10 plus 10 is just 0, so that goes away. And your final answer is 2.5F. Okay, so that is how we combine like terms and how we use the distributive property to help us combine like terms. Down here is your practice. Okay, now I want you to use these colors that you have. You have so many colors to choose from to help you identify like terms. So this is just a recap of some vocabulary if you need a reminder. And then down here, it says identify the like terms by coloring its rectangle using the same color. I'm going to give you an example with negative 3x squared. So I'm looking for all the other x squareds. There's one. That one doesn't count because there's a y there. That one doesn't count because there's a... Oh, that one does count because it's really 1/3 x squared. Here's an x squared. That one doesn't count because there's a y. There's an x squared. And that's it. So that's what you would do that one. Then change your color of your highlighter and then do the next one. And then on these, you're going to take this super, super long expression and you're going to simplify it. So highlight your x's. 5x, 2x, negative 2x, 6x, minus x, plus 3x, plus 15. So 5x minus 2x is 3x. 3x plus 6x is 9x. 9 minus 1 is 8. 8 plus 3 is 11. And 11 plus 15 is 26. So all of those x's simplify to 26x. And then the last part of this is your constants. 40 minus 9 plus 1 minus 8 plus 7. If you need a calculator, get it out. You should have your calculator from last year. 40 minus 9 is 31. Plus 1 is 32. Minus 8 is 24. And plus 7 is 31. So that giant expression simplified to 26x plus 31. Okay, use your colors, and that is what you are going to do with the remaining 9 problems.